Okay, so we're here. All right, well, actually, it turns out it's not as bad here as what I was expecting. Downstairs, those rooms are terrible when those events are happening. All right, so, and I apologize for posting 245, but I will honor my commitment that if you tap your card up to 245, I'll remove the late stuff. Okay, so I promise I'll do it, but I won't be able to do it till tomorrow, so just give me some time and I'll adjust that. Okay, so today is about functions. Well, after one small pause, okay, I know that functions have been covered in the last couple of semesters now in 1101. That's a good thing because at least I don't have to cover the whole background about why we're trying to do it, but I think it's really useful if I kind of repeat it. So we're going to take a problem today and we're going to do it without a function. Then what we're going to do is we're going to turn it into three versions of a function. Slowly the functions get better and better, and sort of ultimately we should end up with something that is a bit more useful. And I'll even show you like some of the code that I end up writing, because okay, I keep saying this, there's many things where I say, yeah, these are really critical. Functions actually are. Okay, they really are really important in terms of being able to write programs, because they give you the concept of decomposition, which is something you would have learned in INFSC 1101. Quite often I've talked about this is when you think about a real program, okay, so something that actually does something important, yeah, we're talking hundreds of thousands of lines of code, and no, nobody writes 100,000 lines of code from start to stop all in one big block of code. They break it up into small sections. Every section you work on one particular thing, because it's the way how you keep everything straight. Trust me, I'm working on something right now. It's maybe it's a couple thousand lines of code. Well, it might be a couple thousand lines that I'm done, and yeah, the functions are what ends up defining everything. Where you say, okay, today I'm going to work on this function. When something goes wrong, you go, oh right, it was something that I did in this function. Let me go fix it there. It's the way how you decompose the problem, so it's more manageable. All right, first thing up, I had a couple of questions about being able to see your results on your labs and quizzes. Okay, the labs, the programming exercises that you get, those things should always be published within 1 week. Okay, I mean, give the instructor like a little bit of time. Don't expect it too soon. Usually I tell the instructors don't publish it until the weekend after everybody is finished. Okay, so you'll see the questions, you'll see the score. You should also see feedback saying this is why you didn't get full marks. Okay, and if you don't, let me know. Okay, and you can get your instructor in trouble because they're supposed to be doing this. If it's full marks, fine, you don't need to say anything, but if they've started to cut down marks and they haven't explained why, please let me know so that I can tell them to please do that from now on. So you should be able to see the questions and the scores, so you'll see exactly how you answered, and you can try it again multiple times as you want. The quizzes, on the other hand, are a little bit different. As soon as you submit, the grade is supposed to pop up. Sometimes that ends up messing up because there's like some weird configuration things that happen in D2L. Hopefully the instructor will publish the grades for you like within like the same day or so. If you want to see the questions that you got right and questions you got wrong, please see the lab instructor, and what they will do is they will show you. Okay, I don't know, traditionally we've never opened up the pool of questions because we want people going off and just memorizing answers to them. Okay, but it is your test, and if you want to see what you've done, it's no problem. Usually the instructor will say, okay, look, this is how you answered, and here was the problem because you thought this. Okay, so just see them. The quizzes are the only ones that we don't publish. Everything else, the midterm, the lab exams, both show up. You'll see everything whenever the grading is done. The final exam, of course, well, no, that's a different story altogether. All right, so moving on. Yep, there's some sections in the textbook, obviously very important because functions are really kind of like the lifeblood of absolutely everything we do in programming. Okay, so here we go. So a real life problem. Okay, so it's a real life problem. You see, even some of the students in lab number 1 saw exactly this problem. It was ask the user to put in a rate, put in the number of payments and a principal amount because they wanted to borrow money. And the idea was, okay, tell us what the monthly payments are going to be. Hey, everybody here is probably going to borrow money at some time. Now, if you think back to, I'm going to call it old days. Okay, I don't have to go back that far. Like maybe 2005 to 2012. If you wanted to calculate payments on a loan, you'd either go to the bank, okay, because obviously they know how to do it, or you might have one of these really fancy calculators with, say, a PMT button that would actually calculate it for you. Of course, you have to learn how to use it. Or you have to have a regular calculator, you have to know the formula, and of course you punch everything in. Given a regular calculator, you can always solve this problem. Yeah, it's a bunch of multiplications, it's some powers, and so on. And even on the lab number 1, a bunch of people wrote answers to this one. So the formula is given. Given the formula, of course, we should be able to produce a program. So, as I said here, if you have a financial calculator, it's great. If you don't have a financial calculator, you can still do it. It just means that you are the person putting in all of the formulas. Okay, always, always, always possible. But what we're going to do here is we're going to write a program. And I'm going to write a program, well, in kind of a funny way, and it says it's going to be irritating if you needed to compute the payment for 3 different vehicles, because maybe you're saying, hey, can I afford the Land Cruiser, or do I have to pick like a Corolla? Okay, I mean, these would be important questions about what you can afford. So you have to redo the calculations over and over again. Simple an advanced calculator, easy. Regular calculator, okay, it's a little bit more challenging. Possible, just more challenging. Of course, what people would do now is they'd open up ChatGPT and say, I want to do this, and it would give you the answer. Okay, but anyway, that's besides the point. All right, if you had to do this 3 times, no problem. Copy and paste the code 3 times. Oh, I've said this before. If you copy and paste something once, there might be a better way to do it, and if you copy and paste it twice, it means there probably definitely was a better way of doing it. But of course, what we do is we use a loop. So what I've done over here in the next page, I'm not even going to run this version of the program because that's not very interesting, but I will start dealing with the functions, and we'll actually try writing the code and running it in a little bit. So here we go. We got a program. You can see it's got the usual type of input, output, and so on. What I'm doing is I'm going through and I'm asking for the various pieces of information. So how many years do you want the loan for? What's the annual interest rate and percentage? There's a bunch of stuff to get things ready. And then for 3 times, I ask the user, what's the principal amount? And I do a calculation. Okay, the calculation, I mean, it's not impossible, but it is a little ugly. It's ugly because it broke over 3 lines, okay? If you had no idea what we were trying to do here, could you guess? And the answer is, yeah, we could probably guess because we see the word payment, we see the word principal monthly rate, and if you've ever had anything to do with finance, you'll say, okay, I think I know what they're doing. They're calculating loan amounts. Okay, and that's completely fine. The formula is a little bit unwieldy because it's gone across a couple of lines, and there's lots of parentheses in here, which can be kind of annoying. And of course, we'll go ahead and print everything. Hey, you know what? Since we're here, I'm going to need this anyway, so let me see if I can copy all this stuff over to the interpreter, and we'll see if the thing even runs. So here he goes. We're going to take a loan out for 5 years. I don't know what a percentage rate is. We'll say it's 5, and I think the 5 should work here. All right, so here we go. Here's a bunch of different cars. So you're trying to decide between a car that's 150,000 versus one that's 200,000, and you're looking for a super big luxury version at 250,000. There you go. Those are the 3 outputs. Okay, so we have a program that we can obviously use. I'm not interested in just using the program. I want to make the program more useful in more contexts. I mean, you are useful in more contexts. All right, let's go back to the slides so we can see the next slide. And we'll have to say, what is a function? Okay, function, this is from infs1201. It's a block of code that's used to solve one particular, very specific type of problem. Okay? Not everything, but one particular type of thing. For example, on the previous page, we did a calculation to calculate the monthly payment amount. That's something very specific. Okay? It's very, very specific. And the idea behind a function is that once we have it, we should be able to take the same piece of code and drop it into any other program that we ever needed in. So the way how it works, and again from infs1101, there are 2 parts to dealing with a function. First of all, you have to define a function where you have to say this is how it's going to work when somebody calls it, and then of course you have to call the function. And we're going to do all of this today, solving that little problem about calculating the loan payment. The idea behind using a function is it's supposed to cut down on the amount of copying and pasting. I don't know, maybe it doesn't always work this way because we already did a loop, so we kind of avoided some copying and pasting. But the really cool thing is that if you write a really nice generic function, you'll be able to take that same piece of code, drop it into another application that you're writing in Python, and still be able to use it. Okay, that's really what we're looking for, is to be able to reuse code. In fact, if it's what really makes it good is if you can take this and put it into a library that somebody else can import. That's the real reason why you do this. And usually the person importing it will be you. Okay? We don't do the importing here. Okay? We just get used to writing the functions. So I'm claiming that it makes the code easier to understand. Okay, well, we'll see an example of this. And as I said before, it's very important because it allows you to decompose problems. Okay, so one thing, and then we will start writing the code. In fact, you know what? We'll cover that afterwards. All right, let's get it out of here. And we've got over here a program. Okay, what does the program do? Well, the program right now seems to be kind of doing a mismatch of everything. But if I had to describe what the program is doing, it's asking the user for the number of years and the annual interest rate. That's good. And then 3 times it's asking for a price of a car and it's printing out the monthly payment each time. Okay, that's what the program is doing. Currently, I'm not using any functions, but I'd like to change this up just a little tiny bit. And sorry, it's going to take me a few times to get it there. Okay, so we just have to be patient. Okay. So my very first attempt. Okay, here's what I'm going to do. You see, in the general case, generally you don't ask to calculate the loan payment for 3 cars. And generally, you're asking for 1. So the first thing I'm going to do is I'm going to fix up my program just a little bit. I'm going to get rid of the loop. I know it doesn't solve my problem right now, but here you go. That's a bit more of a general solution. Okay, just calculate the payment for 1 car. Okay, I can put everything into a loop afterwards. And here's the first thing we're going to do. Okay, again, for my infs1201. I'm going to define a function. So here we go. To define a function, you use the word def. So this is going to define a block of code. You give the block of code a name. So I think what would be really nice would be something like loan payment. All right, here's what you do. The block of code, simply you put a bunch of code, whoops, right here, and you indent, that's too much. You indent everything. If I stop deleting everything, you indent everything that's supposed to be part of it. Okay, there you go. That's a function. All right, this is a block of code. Now, here's an interesting thing. If you try running this program right now, it does absolutely nothing. There you go. It did nothing. All that I'm doing is I'm saying, hey, there's this block of code. It's called loan payment, and it's here ready to go. You see, you're used to using functions already. Print, for example, is a function. But you use it by calling it. And right now, my main program, which is the stuff that appears flush against the left-hand margin, it's not doing anything. That's why this does absolutely nothing. It's a very, very boring program. If you want that block of code to execute, then you have to call it. So we will say loan payment with a set of parentheses. Very, very important. Without the set of parentheses, it doesn't work. So let me throw this away. Go away. Here we go. So if we run this, the very first line that executes is line number 12. Okay, well, line number 1 executes, but all that is says, okay, this is what you're going to do when somebody calls you. And on line number 12, well, now I'm actually calling it. So what's going to happen is now it's going to ask me for the information. So 5 years, 5%. Oops. Oh, okay. I got some issues. Okay, yeah, sometimes this type of thing happens. It says right here on line number 6, in loan payment, so it is actually helping you, telling you exactly where the problem is. On line number 6, it had no idea what car is. All right, well, I can fix that. If you have no idea what car is, I'll just get rid of it. Because remember, it used to be a variable a few minutes ago. I might put it back in a few minutes, but here we go. Let's try it again. All right, so 5 years, okay, interest rate, 5%, 100, ooh, it's not that, 100,000. Okay, and it comes back and it's 1,887.12 per month. Perfect, there we go. So, notice what I did? I called a function 1 time. Oh, okay, well, if you wanted to ask for 2 cars, okay, no problem. Loan payment. There you go. How many times this function gets called? twice. Of course, it's a little bit different because it's going to ask me absolutely everything that we just put in a few seconds ago. So there you go. That's for the first one. But of course, now I've got to ask for the next time. So let's suppose maybe it's 6%, or sorry, 6 years. You're trying to lower your payments. I understand that. And here you go. That's what it would look like if it happened to be 6 years. So yeah, I can save myself 300 riel almost by making it longer. Yeah, if you're banking in fintech, you should be laughing at that going, yeah, the bank's going to make a lot more money. Okay, just work out the interest. All right, but in any case, so I'm repeating the same block of code multiple times. I can use this whenever I want to. I can take this and I can drop it into another program, and inside that program, I can now calculate loan payments. Actually, that's exactly what we're looking for, a reusable block of code. Okay, let's get back over to here, to the slides for a second. So it said right here, to define a function, you use the def keyword, you follow with the name of the function, and parentheses, it's always got to be there, the function names, it says should, must, in 1201, be lower snake case, and you indent the body of the function. Well, that's exactly what I did here. We've indented the body of the function. Hey, what if I want to repeat the same block of code, say 5 times? All that I need to do, like if I had 5 different things, no problem. You copy and you paste and you paste and you paste. I've said it before. Yeah, don't do this. But instead what I can do is I can say, hey, for car number in range 5, and I could say loan payment, and there you go. Now what will happen is it'll ask me 5 times. Same piece of code 5 times. Why do this? Okay. So let me move this out of the way for a second. All right. I'll move this up to the top, make it a little bit easier to see. All right. This is what the program does. What does it do? Not a trick question. What does this program do? This is the only thing you see. It calculates a loan payment how many times? 5 times. See, it's easy. If you try to put this together here, where you're suddenly mixing everything together, it is not as clear. I'm not saying that this is impossible to figure out what's going on. In fact, if we go back and you show this one, it's not impossible, but it is not nearly as clear as that other one. Yes. Right? And that's the whole idea. Here, let me pop open a piece of code for you. Sorry, I can't make the font any bigger. I can zoom in a little tiny bit. That's about it. This one right here, this is a program that I use every week. You see, one of my jobs in this place is to take all of the grades from the D2L gradebook and put them into PeopleSoft. Okay, yes, sometimes 600 students. Do you think I do this by hand? Absolutely not. Okay, so what I've got is I've got a program. Here's a program using some functions. There you go. This is basically all that I do. What does the program do? Well, the first thing I do is I get something called an access token. This is used for gaining access to D2L. The next thing that I do is I say, give me the D2L courses. Okay, you see every course has got their own little ID number, so I need to go and find them. The next thing up is I say, okay, the assessment's going to be set to L2. That's lab number 2. All right, so when I transfer that one, that'll happen. I print it so I can see what courses are in, and I go into a list, and what do? For every course, I get the course grades. That means go to D2L, get the data. How does it work? Well, it's inside the function. Yeah, it's a lot of code. I can show it to you if you're really interested, but it's pretty easy to see what I'm doing. I'm getting all the course grades, and then I'm entering the grades into the web browser. And I do some really weird stuff using a package called Selenium. Really, really cool. And all that I'm doing is I'm saying, okay, open up a browser, and I get the grades from D2L, and then I put the grades in one at a time. Well, I don't do it, the program does. You see, this is really easy to understand. If instead I showed you what's really going on here, you may say that, whoa, this is really quite unpleasant. Here you go. Here's how I get the course grades. There you go. That's how I get the course grades. I'm opening up URLs. I'm doing stuff. I'm iterating through objects. And by the way, you'll learn how to deal with all this stuff. And eventually I'm producing a result. And yeah, I wrote it as a function so that it made my main program easier to understand. Nobody said I had to do it. I did it because it made a whole lot of sense, because the main program is now just, yeah, get the grades, enter the grades, done. And repeat for all the courses. This is why we have functions. Okay, let's put this away. Off we go. All right, so over here, it's not impossible. It's just maybe a little bit nicer when you see it this way, okay? Because it's basically condensed. Now, I'm not going to be doing that very often because I'm not going to have that many things. Okay, I got to press and hold. I hope it's working. Okay, here it is. It's on its way back up. Okay, maybe this will be faster. Here we go. And here to here and go. All right, so here we go. We're back up to here. The main part of the program, pretty simple what it does. All right, now we've got some issues with this. Okay, let me see what I've got because I don't like to bring up the next page just in case. Okay, I'm good with this one. All right, so problems with version 1. By the way, we have version 1. The overall program, the main code, it's really clear to see what's going on. I'm asking for a certain number of car loans. The function, however, is a little bit specific because it only asks about car loans. What if somebody wants to borrow money for a boat? Well, the formula is exactly the same. What about a house? The formula is completely different. Mortgages are always completely different, the way how they're dealt with. But most personal loans and so on, they look exactly the same. It's the same formula over and over again. But of course, the problem is my program says, how much is the car? How much is the car? Okay, and I mean, you could just say, well, it says car, but pretend it's boat. Okay, I mean, it's possible. The output is done using a print statement, but instead of printing it, what if I wanted to store it into a database? Because ultimately, when you apply for a loan, eventually they'll say, okay, these are the payments, customer agrees, it gets put into a database. Okay, well, it might as well go directly rather than just printing onto the screen. Okay, these are things you can't do with version 1 because of those print statements and because everything is very, very specific. It only solves really one problem. I want to make it more generic. So what we do is we introduce a concept called parameters and arguments. Parameters are placeholders inside the function. Arguments are values that are passed in. Okay. So let's get back to this. And again, in infs1201, we would have seen these types of things. You see, I don't like the idea that years is being asked for inside this loan payment because it's very specific about the way it's done. So instead of asking here, I'm going to put in basically a placeholder. It's called years. I'm going to put in a placeholder called annual rate. You could probably just use rate. And the final thing is the principal, which is, of course, the total amount. So I'm going to call it loan amount. Okay, well, okay. I guess less work. We'll call it principal. Okay, we know what that is. So here we go. Principal. All right, here's what I'm going to do. I'm not going to ask for it anymore. I'm going to get rid of those two input statements. I am going to get rid of that extra input statement right here called principal. Okay, so everything is still here. I just got rid of the inputs. If the inputs are gone, then there's nothing I can do. Yeah, here's what's going to happen. You see, down here, I'm going to start asking for these things. So here we go. I suppose I should have copied and pasted. Oh, well, that's all right. Enter years. Okay, here we go. That's an integer. All right, next one up. I'll call it rate. Okay, it could be a float, could be an int. I don't really care. Here we go. Float, input, enter rate. Enter rage, maybe. Sometimes that happens at the bank. Here we go. And, of course, the final is the loan amount. Okay, so this is the amount to borrow. In fact, I'm going to call it the borrow amount. And I'm going to ask for, again, a float. I think makes a lot of sense. Input, enter, amount to borrow. Okay, there we go. So I'm going to ask the user out in the main program. If I run the program right now, what happens? It asks me for 3 values. And then what does it do? Nothing else. The program is finished. Yeah, I didn't actually calculate the payment amount. For me to calculate the payment amount, I need to call the function. All right, so to call the function, it looks like this. You say loan payment. Now, there's an issue with this. I'm going to try running this. Okay, why not? Why not? Okay, so I asked for the years, I asked for the rate, I asked for the amount that we're going to borrow, and I say go for the loan payment. All right, so 5 years at a rate of 5%, the amount to borrow 100,000, and bang, it starts to complain about a whole lot of things. All right, the items that are up here are called parameters. Okay, they're parameters. What these are like variables that exist only inside the function and nowhere else. When you want to make a call to a function, because this function has 3 parameters, you have to provide 3 values. The official name is called arguments. You provide 3 arguments, 3 values, and then that function will be able to work. All right, so here we go. I have 3 values. I have a value called y, rate, and borrow.
It needs to match the parameters and the definition.
Yeah, well, I have 3. Good, I have 3. What I need to do is I just need to pass them in. Okay, now, which one should I pass in first? Hint? Year. Okay, which one of these variables down here represents the year?
Y.
It looks like Y to me. I know we shouldn't be using single letter variables, but that's all right. You can deduct a mark from me later. All right, the second parameter that needs to go into this function is the annual rate. What did I call it down here?
Rate.
Or just rate. All right, and the final is the principal. Well, that's the amount that you are borrowing. So here we go, a borrow amount. Borrow amount. All right, we run it. All right, 5 years. 5%, 100,000. Okay, we're 1,800, I think. All right, 1,887. Hey, not bad. But you see, here's the thing that I'm getting. You see, I can ask whatever I want. I don't have to say the amount for a car. I can ask any question at all. But that function still works the same way. So I can start to put in, please, the amount of the borrow for the car, for the boat, for whatever. Okay, so what I've done is I've tried to separate the input stuff from the actual calculation. I know the output's still an issue. We'll fix that in a second. All right, so here we go. So what I'm doing now is no longer am I asking the user to type things up in the function. I'm going to ask in the main program, and I'm just going to use the function. See, you're used to this already. Everybody here has probably calculated a square root at least once from Python. When you call square root, does it ask you what number you want to calculate the square root of? The answer is no. It's whatever you pass in. Okay, that's the difference. So we're just mimicking exactly the same thing. All right, got a small change. Okay, got a small change. All right, how many parameters do I require? 3. Okay, so. Oh, sir, let me write it this way first. Okay, what do you think? This is actually pretty important. Okay, I got people shaking their head. That either means that you're in disbelief, okay, or you're saying that, no, okay, no, it's not possible. Yeah, this is going to be a problem. And I think probably what's really important is why. All right, remember, line number 9, we've got a variable now called y. Line number 10, we now have something called rate. Line number 11, we have something called borrow amount. And then suddenly on line number 12, we say call the loan payment and pass in years. What's the value of years? It isn't a variable. Yeah, there's a variable called y, but there's not a variable called years. So here we go. Yeah, we get down there. First thing is like years not defined. Sorry, you can't go any further. Okay, all right, that's the first problem. Second one that can be a lot of fun is, oh, what if I use the same names? Okay, years, annual, rate, and principal. All right, how about now? Okay, 5 years, 5%, 100,000, perfect. Yeah, it works. Okay, so a lot of people will say, oh, I'll just use the same variables, and it works. But it's not necessarily really generic, okay? But I'm not saying you can't do it. Usually when I'm teaching a lab, I recommend students don't use the same variables, the same names, because they are 2 different variables. You see, although it looks like it's the same, that's a different variable than this variable. Completely different. There are 2 variables, both called year. You're not supposed to be able to do that. Okay, yeah, that's true. You can't have in the same function 2 variables with the same name. or you'll have trouble. But you can certainly have the same variable in different functions. It's called variable scoping. It's the stuff we'll cover in 2 days. You can do this. This will be fine. Okay, good. So now that we have this, okay, how about that then? Same variables.
You typed it wrong.
Ah, sorry about that. That's printables. Okay, principal. Okay, how about this then? That should be okay. All right, so let's find out. 5-year loan. Okay, at 5% for some car that costs 100,000 riel. And it says result is not representable. What? Okay, that's a little bit bizarre. An overflow. Oops. I think I understand why. Okay, let me just try this again. It's just a theory. 5 years, 5%. You borrow 100 riel, you're going to pay it back over 5 years. I don't think that's quite enough, is it? Okay, it still gave me an answer. Okay, we need to look at this very, very carefully because there's something really important here. I was hoping the other one was going to give me like this outrageous amount. Okay, I should have picked probably a slightly different example. But the reason why this ends up not working has to do with the order that I pass things in. Okay, so very, very important. When you pass in arguments, they go in the same order regardless of what they're called. So in other words, you see, when you ask for principal, it comes in as years. So in other words, what I ended up doing when I said for 100,000, I said, I'd like to borrow some money for 100,000 years. And the annual interest rate was 5%, and the principal was 5 riel, because everything's going in the wrong way. Unfortunately, you have to match up the same order. Okay, so regardless of what they're called. If you pass them in the wrong order, you're going to get completely chaotic results. So remember, it isn't the names that are important, it's the positions. The first parameter, the first argument becomes the first parameter, second becomes the second, third becomes the third. I will relax that next class, but for right now, this is the way how it works. So a lot of programming languages have this requirement. Okay, so here we go. We've got this. You just have to make sure that you put it into the correct order. I'm going to put it back here as Yap, even though I know that I shouldn't be doing this. I just want to make sure that I've got different variable names inside and out. Okay, I prefer the previous ones. First parameter is, what should go in here? Yeah, Y. A second parameter should be A, okay, for annual rate. Oops. Yeah, okay, and this final one is the principal amount. All right, one final check, 5, 100,000. Okay, good, we've got it. All right, so we've made a little bit of progress. We could actually we could copy and paste this and put it somewhere else for some other use. However, I think there might be some issues. All right, so let's take a look at the comments that I put in here for version 2. Okay. So the questions, as in what we are asking the user, this is now in the main program. It's better because now we're separating asking the user for things from the actual computation. Because really, something that says calculate payment, what should it do? Calculate the payment. It shouldn't be ask the user for input, calculate the payment, and produce the output. If it does, that's the name of the function. Okay, nobody wants a function name this long. All right, so our function is doing the actual payment calculation, and it's rather than asking for input. So that's very, very good. But the function, well, can the function be used for things other than car loans? I said it can be, but it has to do with the output. Because take a look at the message that got printed. The payments for this car will be, well, again, what if it isn't a car? See, I want to keep this as generic as possible. I know we could replace this with something like for this item, okay? But here's what I want to do. I want to be able to ask for 3 values, and I'm going to decide which payment was the smallest, okay? And this will pull together many things. Hopefully I've got the time to do it. And right now, if the results just get printed to the screen, I can't make that decision because normally this is going to be like an if statement. Okay. All right, and what we can do is we can comment everything out and we can write the code to check for the lowest in a few minutes. Okay, and I'll show you how to pull these together. All right, so this is the issue that I've got right now. The output still pops out. So instead, what I'm going to do, instead of printing the message, this of course will come into the final thing that you would have learned about functions in 1101, which was the return value. Okay, so the reason why you get information is so that you can use it later. Take a look at, once again, my little function over here. There we go. This was my my grade book transfer. All right, so what do? I go to the courses, I get the grades, I store it into a variable. I then take the variable and I pass it into the next function to say, now enter them. Okay, so I don't just call and let it do it on its own. I actually say, give me the grades. Why? So I can print them and make sure everything's working before I put it back in. That's what I used it for. Okay. All right, so a return is something that you get back. Again, think about square root. I mean, when you calculate the square root of something, when you call square root of 25, it doesn't say the square root of 25 is 5. All that it does is it sends the value back and you do something with it. You take it, you put it into a variable for use later in your program. That's exactly what we're doing here. Okay. All right, so most useful functions compute a value and actually return it. Printing a value is not that useful because the person writing can't, or the person calling it can't make a decision about what was going on. Okay, so usually well-designed functions can be reused across other programs. And yeah, sometimes I do this. I do that gradebook stuff. I've got lots of stuff for going and pulling out grades out of the gradebook. Sometimes I will take that block of code for the function, I'll copy and paste it into another program. I know I'm not supposed to copy and paste, but sometimes it happens. Even if I wanted to be a little bit more nice about it, I put it into a library and then use it. It's the same piece of code. I don't have to write it from scratch each time. All right, if you forget to return a statement, then you'll end up with a bit of a problem. We'll take a look at this, and we'll cover all of these because it probably doesn't make sense for this one. All right, so let's go back and let's fix my program once again. And by the way, me fixing this program, I am not, okay, first of all, is there any problem with my program? I mean, does it work? Okay, it does work. Okay, so it's not yeah, it's a correct or incorrect. So I'm not doing that. It doesn't have any bugs in it, so I'm not correcting it. When you take a program and you modify it so that it is written in a slightly better way, like usually a better way, maybe it's faster, maybe it's just more organized, it's called refactoring. You will see this term will creep up many, many times. It just means take an existing program and tweak how it's doing something so that it's easier to understand, maybe faster, maybe better, but not necessarily more correct. Okay, so if you ever hear me use the word refactor. So I'm about to refactor this program once again. Instead of doing the print statement right here on line number 6, oops, here we go. Okay, what I'm going to do is, just like the square root, here, I'm going to call it monthly, just so I got a different thing. This is what I really want to do. I want to go calculate the loan payment, and whatever that loan payment is, I want to store it into the variable called monthly. And what are we going to do with that? Well, we're obviously going to do something with it. You know what? I'm going to run this program anyway, just as it is right now. What does it do? It asks for the number of years, stored in a variable called Y, asks for the rate, stores in A for some reason. It asks for the amount to borrow, stores in a variable called P. It then goes off, calculates the loan payment, stores it inside monthly, and then the whole program finishes. So 5 years, 5%, 100,000, and there you go. That's the program. Pretty cool, right? Where's the output? Well, yeah, you need to print. Oh, I called the function right there. That's the function. The function was called. Yeah, but we never actually printed the variable. And you might say, well, that's pretty obvious. Actually, you know, in my 3rd year programming course this morning, somebody didn't do a console.log and they were wondering how come you couldn't see it. I mean, eventually it was just like, oh, yeah, it happens, okay? Yeah, if you want to see it, you have to print it. So here we go. Print. Okay, you want to print out some big thing? Okay, the monthly payment, yeah, you know, I'm not going to write all that, is monthly, blah, 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 blah. All right, so now we can finally see it. So 5%, 100,000. Bang. Oh, none. Excellent. I want that car. Yeah, okay, good. So the monthly payment is none. All right, so here's the issue. Yes, this is exactly what you do with the square root. Okay, you call the function, you pass in a value like 25, you get back 5, and of course we print it. But instead of getting back a value, I got back none. All right, the reason why I got back none is because my function is missing something really, really, really critical, and that is something called a return. All right, so here we go. Return means two things. It means stop the function, not the program, but stop the function and send back some information. And the information we'd like to send back from this happens to be the payment amount. That's what I'm going to send back to whoever called me. All right, so what's going to happen now is when I call loan payment, it's going to come back with that amount, whatever it happens to be, the 1,887 some, and of course that is what will get printed. So here we go, 5 and 100,000. Here you go. Okay, it's the right number, but a little chaotic at the end. Yeah, it could really use some rounding. Now, you know, there are two places where I can round it. I could round it when I print it. I could put a round rate here, but you know what? I think I like this one because really loan payment amounts should probably be rounded. So I'm just going to say round here, pass in 2. There's some places how to do this. I think this probably makes more sense. So 100,000, bang, here we go. So here's our 1887.12 once again. All right, now let's go back to my original problem, okay, which was, let's try to read the first program, and I will probably have a lot of abbreviations. Let's do the first thing. Let's ask for the 3 values. Okay, let's ask for the 3 values. And people are always saying, hey, we need more practice in problem solving. All right, so here, we're building up a program this way. Okay, here we go. The only thing is missing is the description of the problem I'm solving. So I'm basically making a problem as I go. All right. The very first version of this program, I asked for the number of years. I'm going to use YRS. Okay, why am I avoiding this? I'm just avoiding it because I just don't want to use the same. We could use the same, okay? I just want to make a very clear point that these are 2 separate variables. But in your programs, use the same names if it makes sense. All right, so years. All right, here we go. Input, how many years? Okay, next one up is the rate. Okay, and that's going to be float input. I'll just say interest, not the integer rate, the interest rate. All right, and the final is the amount. Okay, but if you remember, it was in a loop. And it was in a loop for 3 times. Yeah, perfect, counted loop. All right, so what it's going to do is it's going to ask me 3 times for the following. The amount, okay, we'll make it a float, int float, I don't really care here. Here we go, input, how much is the value? Okay, the value of the whatever. Okay, and here we go. All I'm going to do is I'm going to calculate PMT, that's my payment. To calculate the payment, I need to go to the loan payment function, and I need to call it, but I need to provide 3 pieces of information. I need to provide the years. Years is stored in a variable called YRS. All right, the annual rate is stored in a variable called rate. That's good. And the principal is stored in a variable called amount. All right, and here we go. Sorry, too many things. And let's do this one. We'll say F, and we'll say the payment. Okay, the payment will be, and PMT. Bang, here we go. How many years? 5 years, 5%. Okay, here we go. So here's the 80,000 car, here's the 100,000 real car, here's the 150,000 real car. All right, so now we've got this repeating a bunch of times. I've managed to accomplish 2 things with this. Okay, maybe not as much as what I'd like. Here's the main program, the highlighted stuff. I think it's pretty clear what it's doing.
Yes.
Because I managed to get rid of that big, long, complicated formula. Okay, that's good. I managed to get rid of this really big, weird formula. All right, so that's out of the way. I don't need to worry about calculating the monthly rate or the months and blah, blah, blah. And there's all piles of syntax. It's very clear what it's doing. Ask the user for the years and the rate, and then in a loop, ask for 3 things. All right, let's turn this into something a little bit more interesting. All right, let's go for 5 times. Okay, 5 times. And let me write up a statement about what it is I'm trying to do. Okay, again, I use these as comments. They're just really long strings, okay, but they work really well as comments here. So let's ask the user for 5 5 loan values. Okay, there's going to be a longer description if I was to provide this. Say, ask first for the years and the rate, ask the user for 5 loan values, and tell them which amount will be the lowest of the 5. Okay? Okay. Let me do something for a second because we need to pause this for a few seconds. Let me just get rid of this for right now. Pattern for finding the smallest. Okay, here's the way how finding the smallest works. Okay, it's always the same way, but we better have that first, and it'll be here. I'm just going to put this away. Okay, I'll come back to it in a few minutes. Let's ask the user for 5 numbers and figure out which one's the smallest and say which one's the smallest. Okay, so here we go. The way how it's always done. Okay, we need a list. Or sorry, we need a loop. All right, so let's have. I'm just going to call it number. We'll get there in a second. In range 5. Okay, value int input enter value. Okay, right now. Okay, that much is working. Yeah, it doesn't solve our problem. We solve the problems one little piece at a time. We got 5 loops, 5 inputs. For you to figure out what the smallest of something is, there's a very, very standard way how you do it. There's a few different standard ways. All right, here's the first thing that you do. You have something called minimum. And what you do is you make it a really, really, really big number. Okay, something that's absolutely astronomical. That's a pretty expensive car payment. Okay, so that's going to be way bigger than anything else. And I've got other ways how I can deal with this. Here's what you do. Inside here, you ask the question, if the value is less than the minimum, then what you do is you take minimum and you set it equal to the value. Okay, that's a standard approach. I'm just going to print out the minimum. That's too many M's and N's. All right, so let's give it a try. So if one payment is $1,800, another payment is $3,400, the next payment is $533, and the next is $4,000. Oh, sorry, there's still one more. Like something very big. That kind of makes sense. It's the 533, which is the smallest. Very standard approach. You start with a variable that contains an absolutely astronomical amount. There's more way to do this. And then whenever you find something that's smaller, you replace it. Okay, and this will tell you the smallest. If you don't really like this approach, there's a couple of other things. The usual way is to make it equal to the very first item. In a for loop, it's really tricky. It's possible, it's tricky. Okay, so I'm going to give you some of the options. This one I kind of like. I'll give you another option. Okay, is there a number that's bigger than 999, 999, 999, 9999? Is there a bigger number? Yeah, sure, add another 9. So what if we just say keep on going and going and going and going and going and going and going? Yeah, I mean, there's a way, but okay, think back to your math class. Is there a number which is bigger than all the other numbers?
Infinity.
Yeah, infinity. Okay, good. So the question becomes is how do you spell infinity? Yeah, it's spelled INF, but you have to do some weird stuff with it. You have to turn it into a float, and you have to put the INF inside a set of quotation marks. It's kind of weird. Don't worry, I'm not going to ask a question about this. This is for your own stuff. But this literally means infinity. And guess what? The next number that's put in will be less than infinity. So the whole thing will continue to work. Okay, there you go. So out of all of those, 2 is the smallest. But it is kind of a way to initialize the minimum to be something absolutely astronomical. I've got another way as well, but I think this is probably a little bit cleaner. Okay, and I reserve the right. We might change this in a few minutes. All right, so here we go. So now we know how to pick up the smallest. So let's go back and let's put this into our function, or sorry, into my actual program. Okay, does it have anything to do with the loan payment? Absolutely not. Has nothing to do with the loan payment whatsoever. That piece of code is completely reusable. I can use it in any program that I ever want to. It's not asking to use it for anything. It's not printing anything. The only thing that's a little bit restrictive is it rounds to 2 decimal places. That's the only thing that it's doing that I would really consider restrictive. Otherwise, it's a very, very generic function. Okay. You see, it's something that goes on here. All right, well, let's pick up the minimum. All right, just before the loop, let's have the min payment, and we're going to set it equal to something absolutely astronomical. Okay, that's pretty big. If you want to use a pile of 9s, I'm okay with that too. All right, so you set this up. What do? Well, after you get the payment amount, you ask the question, if the payment is less than the minimum payment, well, then the minimum payment becomes PMT. All right, and at the very end, we're just going to print that, here we go, the smallest payment is, whatever goes in, min payment. All right, and we clean up all this stuff. This is modular programming. You work on one little piece at a time. And you see, now it makes a lot of sense because we just saw this. Okay, there could be errors. All right, we'll find out. All right, 5 times. Oh, really? Okay, 5 years at an interest rate of, let's make it fun, make it 12. You don't want 12%. It'll be really bad. Okay, so you go and you say, okay, I'm going to buy the 250,000 real Land Cruiser, and it comes back at, woo. Okay, maybe you can afford it, maybe you can't. Let's try some other things, 125,000. That's pretty decent. You get something much cheaper. Nissan Sunny, right? I have no idea how much one of those things are. Probably this much now. Hey, that's pretty small. And we'll try something that's absolutely enormous. Okay, 800,000. Can anybody afford that? I don't think I could. But in any case, here we go. And maybe just one more thing. We'll pick something that's kind of normal. Maybe 200,000. One more, bang. Here you go. So look at that. The smallest payment was, there's the amount. So what we've done is we've combined a couple of things together. We combined finding the minimum, and we combined finding the loan calculation. Now, take a look at this program right here, okay? Because I'm always interested just in what we've got in the main. All right. It's not as clear. Okay, and I completely agree. It's not as clear. But take a look what I don't have to look at. I don't have to look at that big long calculation which took 3 lines. It's now just one thing. That's an improvement. Okay, are there things that we could do to make this even better? Like maybe we can find the minimum in an easier way? And the answer is yes, you can. I can't do it yet, but if we have lists, it's really easy. Okay, but that's coming in a couple of weeks. All right, so what I've got now, by returning the value rather than printing it, I can now reuse the same piece of code in other contexts, right? I can use it, maybe I'm trying to figure out the maximum. Maybe I'm trying to not only figure out just the smallest payment, but also what was the price of the one? How much interest am I going to pay? Oh, I could easily have a function called compute interest paid. It'll be a different formula. And when you finally have it, then you can call it and you can figure out what the interest that you're actually going to have to pay. It's very, very flexible. This is the whole reason why we have these things. Okay, let's see what we've got up here next so I don't forget anything. Okay, 307, so I did say we'd probably go pretty much to the end. I promised by 320 we'll be done. All right, so comment about number 3. The result is now returned rather than printing. Okay, very, very important because although we could print it inside the function, we don't know what the real program is going to do. One of the things that I quite often do is I write little functions that I think might be useful later. All of those things about pulling out the grades out of the book, out of D2L, yeah, I wrote that one day, said, hey, could I get this information? I didn't know what I was going to do with it. Well, eventually I figured out, I know I'm going to put it into PeopleSoft, but sometimes I just write these little functions to see how they work and return things so that I can use in different things. Like, for example, sometimes I go through and I say, okay, I'd like to take everybody's grade and I want to give me the 10 best students. Never look for the 10 worst students, don't worry. Give me the 10 top students out of these grade books. Show me who's doing really well on the labs but did really terrible on the midterm. I want to know information like this because I want to find out why. Okay? I'm not going to answer why. It's just, but maybe you want to say, okay, look, these are the patterns that I happen to be observing. Do I have people who've missed more than 2 assessments? Why? Okay, I can pull that information out of the grade book, and I can still use that same function. That's what functions are here for. So you could take the function, put it into another program. Okay, I do that all the time. Or better yet, put it into a library and everybody else can use it. There are functions out there, for example, that open up Excel spreadsheets. And you can find the source code for them. Yeah, I don't write that stuff. I just use it because somebody else has written it. All I do is I call the library called open spreadsheet, give me the value out of this cell. So the idea is you actually never need to write another loan payment function ever again, because now it's here. Okay, and it's as generic as possible. And the next slide up, it said that, yeah, you've actually been using functions all along. Print, length, int, yeah, these are all functions. You can find source code for them. I think I managed to find a little bit of source code for print. It looked like about 40 to 50 lines of code. You get to call just one thing. And trust me, there's a lot more going on than just 40 or 50 lines of code. There's a lot of things. The square root module for math. How many people know how to calculate a square root if you don't have a calculator? Anybody? Does anybody know how to calculate the square root of a number without a calculator? Okay. If you've taken Math 1030, you do. It's called Newton's method. Okay, so just to put in context, everything is related. That's essentially using Newton's method, okay, which is a way how it kind of approximates things. Okay, well, that's kind of an interesting thing. But the good news is you don't need to know Newton's method. Somebody else has already done it for you. Just go ahead and use it. And it doesn't print stuff. It doesn't ask the user for things. You pass in the value, you get back the response. Let me do a couple of extra things in here. I've got a few minutes to cover. Okay. For this exercise, I'm going to make my main program a whole lot easier. Okay, and it's all gone. Okay, I'm going to print loan payment, 5 years, 5%, 100,000. There you go. Is that allowed? And the answer is absolutely. Okay. All that I'm doing is I'm saying, please call the function called loan payment. The value of years will be 5. The annual interest rate will be 5, and the principal will be 100,000. I don't have to type anything. Excellent. I can use this test without having to keep typing it 5, 5, 100,000, 5, 5, 100,000. Now it just goes ahead and does it. And now I can use this to figure out maybe if I've got some problems. All right. I'd like to start messing up some stuff. Okay, here we go. What would be a fun thing to do here? Okay, what does this mean? I am going to borrow negative 100,000 riel for 5 years. So if you're going to borrow negative, what you're doing is you're giving it to the bank.
You're gonna get paid.
Yeah, you're going to get paid. Now, unfortunately, what happens is you start to get some really weird numbers that pop out. You start to get negative values, and yeah, I mean, it could actually work this way. If you're going to lend somebody this much money, so much money they'll give you. But if you say, you know what, I just don't want negative values because my function is all going to be messed up if I got some negative values. There are some values in here that'll be absolutely terrible. Okay, like negative rates will probably be really weird. Would anything be an issue here that I could cause some issues? I have a feeling if I put in months at 0, I think I might start to have some issues. But I just want to cover one thing before we go. Okay? All right. What's the value of principal when I hit line number 8? In this particular case. So when I run this program, what's the value of principal? Like if I were to put this statement right here, if I said print principal, okay, what would I see? Yeah, minus 100,000. Okay, yeah, it's just whatever got past it. All right, if we have decided that minus 100,000 is a bad result and we don't want to do the calculation because maybe there's division by 0. That's what I was looking to see if I could get a division by 0, but I'm not sure. It's a little bit more complicated. But if I wanted to make sure that I never had that happen, here's what I could do. And I'm not saying this is a good solution to this, but I want to, because I saw a statement on the slides and I want to justify it. Okay, and a lot of students end up missing this, and I don't just mean 1201 students. Students who end up in third year also end up with this because I was in a different theater just the other day and somebody asked the same question, and I said, no, remember the following. All right, here we go. Okay, if it's less than or equal to 0, okay, if it's 0, it's probably okay. If it's less than 0, okay. Okay, we have a problem. Okay, the program continued, but we did have a problem. Okay, now I would like to actually tell whoever called me that I really had a problem. I mean, yes, obviously we're printing the message, but remember, who sees the printed message? The user. Who sees the return? The program. You need to tell the program that we had a problem. So here's what I'm going to do. Instead of printing a message, I'm going to do something a little bit weird. Okay, I'm going to stick a return. Okay, now, I'm going to try a few different things, and then eventually we'll kind of conclude on what we want. How about this? Okay, I've just made up a number. I'm more interested in just tracing out what the problem does. So I'm not going to put so many nines. Three nines for right now. Okay, just 3 nines because I won't be able to say all of those in a few seconds. All right, and here's the thing that I want to ask. Wait, first of all, if I go back and I make this positive, what happens? I get the program completely runs and the answer is 1,887.12. Exactly as it is. Minus 100,000. Now, we've got an issue because if you take a look at because the previous one, the if statement never was true, so therefore line number 8 never happened. This time, line number 8 is going to happen. And line number 8 says return negative 999. All right, but then there's another return on line 13. Uh-oh. So what gets returned? Is it the minus 999 or is it the 1,887.12 with a negative sign, or is it those two things added together? Yeah, good answer. All right, so here we go. It's the negative 999. Yeah. Here's what happens whenever a function hits a return. Remember what it says. It says there are two things that happen. The first thing is that the function immediately stops. Nothing else goes. It doesn't matter if you're in an infinite loop. That will stop the infinite loop because it will stop the function. Okay, the function is finished. Whatever shows up after the word return is the value that will then be sent back to the main program, and then the main program will carry on with whatever it's doing. Okay, in this case, it got back a minus 999. Now, I suppose what you could do in the main program is you could say if the lone result ends up as minus 99999, then you could print a message saying, hey, there was a problem with the input. So you could do this type of thing. Magic numbers like this, they used to exist. It was never minus 999. At the time when I was going through programming, you'd return minus 1 to say it was an error. Which, of course, works perfectly fine if the result was supposed to be positive. But there's been lots of cases. I had a case happen in our company where somebody returned minus 1. It caused all kinds of chaos. I've got a video somewhere on the internet. I will share a link with you. And basically what happened was somebody in a piece of rocket code sent back minus 1, and the rocket blew up. It cost somebody $5 billion because they didn't check the result to make sure it was minus 1 before continuing on. So I'll find a link. Sometimes I would show it. If I had an extra few minutes, I would, but I know I'll run out of time. That's one approach. Okay. Another approach that's very popular in Python when things go wrong is, what if I just don't return anything? Oh, sorry. Habit. What if I just don't return anything? Well, if you try returning absolutely nothing, you get back the word none. Now, I have to do a quick demonstration, 2 minutes and we'll be done, about how you deal with this. Most of the time, I would actually type the word none. Okay, it'd actually say return none. It would be the same thing. So instead of returning the payment, it returns none. And what I could do is I could do something like this. I could say PMT is equal to this, and I can ask a question. If PMT, then I can print out the PMT amount. Okay, otherwise, and yeah, include other messages. Otherwise, I could print out that there was some problem with the, who knows, whatever the problem was. Okay, so here we go. So there was some problem. All right, and if I use something that's kind of normal, okay, then it looks this way. Yeah.
Why say return none instead of just return that it's the same?
It means the same. I usually make it very, very clear when I'm returning none to say this is what this is what's happening when I've got an error. Okay, it's just to make it really, really clear what's going on. The only thing I want to point out about returning none, and then we'll be done. Okay, so none and done. Okay, almost. Oops, not this. That is not the same thing. Okay, that is a string containing none. Okay, as opposed to the actual value. You see, this ends up not working because if you try this, ooh, actually, luckily, because it actually returned the string none. But if I now try to multiply this by 12, it's going to blow up. It's going to say no, 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 no. So just keep this in mind that this is an actual value, not a string. So if you ever see a request in any of the assessments that say return none, it actually means return none, not the string called none. All right, final summary then. Okay, then we are finished because we're out of time. Normally, the data goes into the functions via parameters. In other words, you normally don't ask the user inside the function. Okay, so just keep that in mind. Data normally comes back as a return value. You don't print it. The only exceptions is whenever the function says, write a function that asks the user for input. Well, obviously you're going to ask the user for input. Or write a function that prints the following. And in this course, it'll almost never happen. So if you find yourself tempted to use print statements inside any function in this course, you probably have a misunderstanding about what's being asked. Doesn't mean it's guaranteed, just double check to make sure that's really what you're supposed to do. So normally data goes in as parameters, comes back as a return. Everything we do in this course will involve functions. So on the midterm, you'll be asked to write 2 programs. Oh, sorry, you won't be asked to write 2 programs, you'll be asked to write 2 functions. Function that does something with a list, another function that does something with a list. On the lab exam, you'll probably be asked, I think we now have 6, you'll be asked to write 6 functions. On the final exam, you'll be asked to write 2 functions. Yeah, we hardly write programs anymore. We write just functions because these are the basic building blocks. The main parts of the programs, if they even exist, it's really just to ask for maybe 1 or 2 values and that's it. You'll find that the concepts that we cover here mostly fit within functions because this is what we need. Because what you need to go forward. Okay, so sorry I'm a couple of minutes beyond. And again, for anybody who came in late, because I accidentally said 2:45, I will continue to honor that. If you tapped your card before 2:45, I'll clear the late flag, but I'll have to do it tomorrow. Okay.